Number 57. Danny is 5 feet 8 inches tall. Outside, he casts a shadow that is 16 feet 6.6 inches long. At what highest speed is the end of his shadow moving away from him? So I'm going to draw a diagram. So here's Danny, here is his shadow, and let's say the sun is right here. And there's a light ray that connects the top of his head to the end of the shadow. And I'll call this angle theta. So let's see. So his height, he's 5 feet 8 inches tall, so that's 68 inches. And he is 16 feet 6.6, or the shadow is 16 feet 6.6 inches long, which is 198.6 inches. So the question is, when will the shadow be moving away at the highest speed? Well, that will be when theta is changing at the maximum possible rate. So if you think about this, in a day, there is one rotation, which corresponds to 2 pi radians. And a day is also 1,440 minutes. I'm using minutes because that's what our answer is. That's where our answer needs to be in. So this will give us our angular velocity in radians per minute. So 2 pi over 1440 will simplify to pi over 720 radians per minute. So the next thing we can do is we're going to set up an equation using the properties of a triangle, just trig ratios in a triangle. So I have an angle, I have the opposite side, and I have the adjacent side. So I'm going to say tangent of theta equals the opposite side, which is going to be a constant 68 inches, over the length of the shadow, which I'm going to call A. So if I take the derivative of both sides here, on the left, derivative with respect to time that is, I'm going to get secant squared theta d theta dt equals negative 68 a to the minus 2 dA over dt. If this is unfamiliar to you, I'd recommend brushing up on some power rule and chain rule, implicit differentiation. That's the kind of stuff we're doing here. But for now, I won't cover that right now, though. So we have this equation here. Secant squared is the derivative of tangent. So secant squared theta times d theta dt equals negative 68 a to the minus 2 times dA over dt. So dA dt will be the rate that the shadow is moving away. If you think about it as that's the rate that the length is increasing. So if I solve for dA dt over here, I will have, let me get rid of this real quick. dA dt, I'll have secant squared theta d theta dt on top, and on the bottom, I'll have negative 68 a to the minus 2. So I just need to find out what all these values are. So to find theta, well, for theta, I can just use this triangle over here. I have the opposite side and I have the adjacent side. And so theta will be the inverse tangent of 68 over 198.6, which is theta is equal to 0.32989. So now I know theta, and I can take the secant squared of that relatively easily. And then d theta dt, we've already figured that out. That's just the pi over 720 radians per minute that we figured out earlier. And then negative 68 a to the minus 2. Well, a is just going to be the length of the shadow at that time, which would be 198.6 inches. So if I plug in all of those values, let's see. So secant squared of theta, well, first of all, let's find theta. So it would be the inverse tangent of 68 over 198.6. Right, that's what we got before, 0.32989. So this is going to be secant squared of that. Secant squared multiplied by d theta dt, which is pi over 720, over negative 66 times a to the minus 2. So times 198.6 to the minus 2. And we get a value of 2.91. I'm sorry, we're not using 66. we're using 68. Was I using 66 before? Nope, I was using 68. Here we go. 68. I just typed the wrong number. So let's see. So we get a value of 2.83. So that's going to be our final answer. He's moving away. Maximum speed is going to be 2.83 inches per minute. All right, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I'll see you next time.